We should be live in a moment, but I'm going to put on headphones.
Yay.
Okay, we're live. All right. Maybe, in theory. What's going on? There's some kind of live stream that's happening. Wasn't there supposed to be a launch of the Dragon, and then it got punted a week? They were going to be launching or SpaceX was going to be launching
Yeah, at
today.
3 a.m.
Yeah, and then it got punted for a week.
Right, because they're
Be-
going to clean up.
oh, there was a problem with the drone. With the, of course, I still love you.
Okay, that part I didn't know, but the reason they're giving it a whole week is because they're going to work on cleaning up the mess they made.
Yeah, with the Crew Dragon.
Yeah,
Yeah. Yep. Which sucks.
mistakes were made.
Yeah, yeah. There was an anomaly.
Did you see the story how DOJ working with NASA figured out that two
Yes.
past failures were faulty aluminum?
Yes. Like that the company that had provided the aluminum had made,
Falsified.
yeah, had falsified their quality assurance data.
Yeah, it
That's
was
bad.
bad.
Yeah. I'm going to say hi to a bunch of people. Hello to Andy Cowley, Astro B, Bill Sugden, Bor Clankar, Catalin Bontia, Don't, Jim, George Lancaster, Gordon Dewis, Graham W, Guido Bibra, Harry M, Harry Patrick, James Aberson, Jim Smith, John Seffield, Jordan Albert, Kai Roach, Catherine Okonski, K Spence 303, Kaylee Cerna, Linda Sadiq, Nancy Graziano, Nichols of the Yard, Ocean McIntyre. Everybody's here. Paranor, Paul Gracie, Peter Wyoof, S. Wolberg, Thomas Traneker, Tom Van Scotter, and Zapfan. Hey, everybody. So just to let you know what's going on today, we've got to do a double episode back to back, all within the hour. We don't have any time to spare. We're just going to get started right away. We're going to do one episode about the ancient Andes, and then we're going to do another episode all about the modern Andes, the big telescopes, the big scopes. So, whenever you're ready, we will have to get started.
I am pressing record. It is recording.
What? I find
Susie.
that hard to believe. Are you sure?
Yeah.
Okay, here we go then. Astronomy Cast, episode 529, Ancient Astronomy in the Andes. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Good. Now, we are recording these episodes back to back this week and next week's episode, so if something really exciting happens, we apologize in advance. We are banking an episode, but you're going to go somewhere interesting?
I am. Next week, I will be in Budapest, Hungary, a country I have never been to. And I will be giving the opening keynote at Craft Conference, which is a software developers conference. And I'm feeling totally overwhelmed. Imposter syndrome is real. The individual whose name I'm not going to mispronounce, so I'm just going to not say it,
Right.
who developed the C++ programming language is going to
Yep.
be there.
Oh, that's amazing.
I'm not worthy.
Oh, that'd be great. It'd be great to one programming nerd to another. It'll be perfect.
It's true.
All right, well, let's get into this week's episode. So, the Andes Mountains in South America are a hotspot of astronomy today, but ancient peoples knew it was a great place for astronomy and lived their lives in tune with the night sky. Today, we'll learn all about what they knew and how they mapped the movements of the stars and planets. So, 2 weeks ago, we talked about the ancient astronomy of the American Southwest. That was great. Turns out they weren't the only ones watching the night sky. What was happening in South America over history?
Well, so the first thing I want to do is try and paint a map of where everything was. So we've talked about the Mayan a bunch before because the world did not end in 2012. And the Mayan were located in the Yucatan Peninsula. Then we also have the Aztecs, they're more Mexico City. The Inca were along the Andes Mountains. In general, Peru is the country that is most associated with the Incans, but Chile is a place too, and they were located there as well. These artificial national boundaries we have today have nothing to do with the original cultural boundaries of these people. So the Andes mountains are the places that the Incas were located. And what's amazing is these are places where the sun was straight overhead a
Yeah.
couple of times a year, and that played a major role in how they viewed the sky.
That's great. Right. I mean, we're always so. I mean, we in the northern hemisphere, me much farther from the equator than many people. We're just. I'm always just so used to the sun making this sad, pathetic journey across the southern sky. In the middle of winter, it shows up at like 9 a.m., 9:30 a.m. Just dips a, just pokes its head up and then heads back down at like 4:30. And then in the summertime, it lasts a little longer. We get it's up at 5 and goes back down at like 10. But I can't
Yeah.
imagine what it's like to stare straight up overhead and see the sun directly, where shadows just don't exist.
And that was the thing. One of the key features of how they viewed the world was they would build these giant gnomon, these uh, straight up and down sticks, for lack of a better way to put it, and they would climb these sticks to get closer to the stars, which were in some cases identified as their deities. And beyond that, they also built these gnomon in order to figure out different key dates of the year. And so, depending on exactly where they were, it wasn't going to be a solstice or an equinox when the sun was straight overhead, but there were key days when you looked at those sticks, and those sticks had absolutely no shadow. And this is how they marked the passage of the year.
Wow. And so what would they be looking for apart from like someone should tell them that if you climb a stick you're not that much closer to the stars?
It was a noble idea.
Yeah.
It wasn't a valid idea,
Right.
but they tried.
But what could they then use these moments of knowing they were at the I mean, I guess it depends on where you're going and it depends on what latitude you're at, what that means. But I guess
So,
anywhere, as we learned in school, anywhere between the Tropic of Cancer and Capricorn, you'll have your moment when the sun is directly overhead.
exactly. And this would tell them where they were in their local year, and the results would vary depending on where you were. And they coupled these gnomon with also a lot like we saw here in the American Southwest. They would create observatories where the shaman would stand in the exact right place and look out towards the horizon and look for the sun, the moon, generally the sun, to rise or set between specific pillars that would be built off
Oh,
on the
cool.
distance. And so they were forever building things. And for this, we are mostly grateful. The problem and the reason it's not completely grateful is the Spanish.
Right.
So, unfortunately, the Spanish conquistadors tore down most of the easily accessible relics, and people have had to try and piece together what was where, and in some cases figure out, okay, if I follow this llama track that has pottery shards all along the llama track, get far enough out, climb this hill, oh, this is where there used to be sticks erected. And that's kind of a miserable way to do archaeology, but this hasn't stopped archaeologists, who may be the most self hating of all scientists.
Right.
And so they have tracked all over these mountain regions, trying to piece together the cities, the alignments, and figure out how it was that they marked out their calendars.
So then what do they think that they were doing based on the tiny clues that they found so far?
Well, it's clear that they were trying to figure out, when should we plant, when should we harvest, the normal things. Like so many societies of the world, they had celebrations for midsummer and midwinter and the equinoxes. And the Incan people, found that their universe was one continuous, united whole where there were relationships with the stars, there were relationships with even the dust in the Milky Way. The Incans were one of the only peoples, uh, not the only, but one of the only peoples to have both star constellations, which they considered inanimate, and also dark constellations made out of the dust in the Milky Way, which to them were animals that were very much alive and moving through the plane of the Milky Way. So I just love this idea that the stars were static and dead, and the dust was alive with animals.
One of the places that I really want to go, like as a child, I've wanted to go to Machu Picchu,
Mm.
and that's an example of a place that the astronomy is was definitely happening there.
There was a vast solar observatory that has long been known about, and it was someone in the heart of the city. It was where ritual sacrifices took place.
Of
So,
course.
not so much a fan of that aspect, but we're still exploring this vast city. And it was found just back in 2012 that it appears there was also an astronomical observatory that was used to mark the rising and setting of the various stars. And we still don't understand exactly how everything fed together. We know that other cultures, for instance, the Greeks saw the rising of Sirius, the dog star summer, as adding heat to the hottest month of the year. We've lost too much of the culture of the Incas. It was purposefully eradicated, purposefully killed out. And so we may never know, but at least by finding these places, by doing laser recreations of them in software so that we can explore all possible alignments, it's starting to give us hints of what's possible. And this ability to use archaeological maps in combination with planetarium software is something that was first done actually for the Incan Nazca lines and for Stonehenge. And while Stonehenge was really good at offering up clues to why it was there, the Nazca lines are more annoying.
Now, I mean, we, as science explainers, have definitely run into the Nazca lines, and there's a lot of nonsense out there. So, but they're a real thing, and they're actually
Yes.
pretty amazing. What do scientists think they probably are? Like, if you went there right now, what would you see?
Well, so what we'd see is there's three different kinds of Nazca lines. There are ones that are made subtractively. So the Nazca lines are out in the Atacama Desert. The most prominent, most well-known ones are in the vicinity of Nazca, Peru. There's also lines on the Chilean side of the Andes in the Atacama Desert. And these two suites of lines are made either by people removing the darkened topsoil that has been made a rusty color through interactions with solar UV light. There's like no rain there, no rain pretty much
Mm-hmm.
at all, a couple millimeters a year, maybe. And by going through and removing this UV altered soil, they can reveal the white stuff underneath. And what is cool to me is this isn't all that different from how we're able to see the trails of dust devils on Mars, where it reveals the subsurface soil that's a different color. Now, it's a really subtle effect. And in some places, rather than simply stripping off the surface material, they also gathered rocks and pebbles and added that on top of the surface. And in some places, they did both. They scraped off the topsoil and piled rocks. And these lines are kilometers and kilometers across. And you can't really figure out what the heck it is that's out there until you fly over it. And in fact, these Nazca lines weren't even known to modern peoples until the 1930s when regular commercial air flight started to take place.
That's such a crazy discovery that you would be flying overhead and see some recognizable shape. that people had been crossing for all their lives as they moved around the desert and never had an idea of what it was. And finally, we get some perspective. So, I mean, if your average person would have no sense of what it is that they were looking at, it must have required tremendous math for them to figure out how to lay down these lines in a way that was recognizable by who? By the gods? Like,
And this is where you start to get all the crazy internet
yeah,
rabbit holes that
right.
unfortunately have far more YouTube hits than we do.
Yeah, exactly. Yeah.
So
Go
so
ahead,
there
search for Nazca lines on YouTube. I dare you.
on the more benevolent side of we don't think this is true are the theories that they actually had hot air balloon technology. And people have been able to create hot air balloons out of things that the Incas are known to have had, but there's like no records of hot air balloons. And it kind of seems like that's the thing there would be records of. So that one falls under the category of mostly harmless, could be true, probably isn't. As we go down towards the crazier and crazier ideas, we start to hit the aliens have visited, and these were built in worship of the aliens or built by the aliens, built with the aliens. I inadvertently came across an article where one of the people who'd been preserved in the glaciers was viewed as being an alien
Right.
instead of a human. Yeah, there's lots
Yeah.
of crazy. Don't go there, people. Don't go there.
But you can kind of imagine the thought process, right? Which is that they're saying, okay, we think the stars are the gods live among the stars, and so they make an estimate. You know, they climb the top of a mountain, and the stars don't get any closer. They go to the bottom of a valley, and the stars don't seem to get any closer. So they know that the stars are really far away, and so if they want
Yeah.
to show their dedication and devotion to the gods, and they know how far away you can see something.
Yeah.
So they figured we would have to make something really big in a place that was really flat as our big easel. And then they did the math to figure out how to map some small drawing that they'd made to something that was very large so that it could be visible to really
And
far off.
and we're not even sure if that's really the reason that that was done. More recent studies are starting to explore the idea that maybe, yeah, the giant spider in the desert probably had ceremonial reasons. But these lines come in a variety of different patterns, ranging from geometric to that's an animal, that's a spider, that's a monkey, that's an eagle. And some of these shapes seem to be indicating over here is where you can find water, over there is where you can graze. And so there may have been a joint ceremonial and informational use to having these Nazca lines. And this joint, everything is united, is very consistent with what we know of the Incan people who did see it all as one continuum of we're all united. Now, there have been, falling down the rabbit hole again, some interesting articles that probably aren't true, but since we can't go back and interrogate the people who built these lines hundreds to thousands of years ago, or hundreds to over 1,000 years ago, we don't know. So there is one researcher who feels that the great spider that is spotted out there is actually a projection of the constellation of Orion onto the surface of the planet as viewed by a very different culture. And so there are lots of attempts to try and unite the is this pointing to water? Is this pointing to grazing? Is this just showing off? We see you up there, stars
Right.
that, well, make Orion or make a spider.
Yeah.
Pick your translation.
Right. So, admire our devotion, gods. We built pictures that you can see from space. Or they serve some way to memorialize the constellations as they understood them. It's a fascinating mystery.
And the Incan culture was huge. It spanned modern day Peru, parts of modern day Chile, and there were vast trading paths for llama. And these Nazca lines weren't associated with any ancient cities that we can tell, but they were along the llama routes between the different cities that did exist. So part of me also wonders how much of it was this was just part of what people did as they traveled back and forth across this horrifying desert. Was this a hello God, please don't kill me. I'm going to make this pattern a little bit bigger. Uh, what what exactly was the purpose? We can't ever really answer, and that's part of the beauty of it.
That's really cool. Uh, any other regions that are located in the area that have some interesting astronomical significance?
Well, we're going to get to most of that astronomical significance in our next episode where we hit on all of the different observatories. But I think with this, the one thing that we probably skipped over way too fast because I was excited about getting to the Nazca lines
Yeah, me too.
uh, was how they used these gnomon indicators, and the mythology associated with this is fabulous to think about. So they were erecting sticks. It's what they did. And in their tradition, August was some of the most important time of the year because here, Southern Hemisphere, you do your planting in August. And because they weren't exactly on the equator, August was when the sun came along and sat squarely on the top of their poles. And this is how they viewed it. They actually viewed harvest time as when the land parted and the farmers planted their seed in the earth. Take that where you will. That's what they did. And at this point, the sun has paused directly overhead to, um, well, fertilize the land. Take that also how you will. And so you have this idea of the sun sitting atop the stick. And there were some rather crude ways that early archaeologists put this, which I am not going to repeat, but I will let your imaginations go there. Now, in addition to this day when the sun was straight overhead, they also held ceremonies for when the sun was at its anti zenith, which is something that we haven't really seen in other cultures. Now, again, unlike most of the cultures that we have looked at, their sun was straight overhead. Greeks didn't have that going for them. The Americas didn't have that going for them here in North America, where we have the Navajo and Zuni and so many other histories. But the Inca had the sun straight overhead. And so instead of having their celebration for winter solstice, they did have their celebration for winter solstice. They also worried about that exact moment when the sun was directly beneath their feet. Now, you can see exactly when the sun is straight overhead. You put up a stick, you look for the shadow to go away. That's easy. Now, they also figured out when the rising and setting points where they were on the sky. And it turns out that you can use geometry to figure out, based on these sunrise and sunset positions, exactly where the anti sun is. So, specifically, when the sunset beams in the morning hit going straight across the land, the sunrise beams go straight across the land to hit the sunset point for the zenith. That was when you were looking at the anti zenith sun.
Well, hold on. So is the anti zenith sun then in the middle of winter, or is it like
It's in the fall. So if you have zenith occurring in August for planting,
right?
then you're going to have anti zenith in spring,
Is it
and they have a
so? Is it? I'm just trying
celebration
to
for it.
imagine the geometry here. Is it dependent on how far away you are from the equator? Because,
Yes.
right, okay. So if you are right at the Tropic of Capricorn or Cancer, then you're gonna get the sun going directly overhead. Uh, is that at the
Very
solstice?
close together. So that will actually
Yeah,
both be in the spring.
right. But if you are farther away, then you're going to have this moment as the sun is directly overhead, and then a couple of months later, you're going to have this moment where the sun is directly underhead.
Right.
Right. I
And I
see now.
misspoke. It isn't exactly spring and fall. That is a conceit of making the geometry far too easy in my head for a moment. So if you're directly off the equator, so a few days after the equinox, when the sun is directly over the equator, you'll have the sun directly over your head. You then wait while it travels north. It goes through its extreme, travels south. So it's right before that next equinox. So here you do have fall and spring. But if you're right next to the equinox position, it might be like 3 days apart if you're right
Right.
next to that equinox solstice position. If you're right next to that solstice position, it's just going to be a few days apart and it's both going to be in the same season.
Right. And the point being that if you appreciate the sun and celebrate its directly overhead, then they were most nervous about it having the least amount of sun. The point where it was directly or
Well,
the most anti-sun. I just like that idea, right?
it's not least sun, it's
It's
anti-sun because
anti-sun,
least
yeah.
sun is other side of the
Yeah,
equator
it
doing
is
other things.
directly below your feet. It is as
Yeah.
below your feet as the sun can be, which is such a clever idea. I like that. I like that.
And it's always fascinating to see how different cultures connected with the sky in both useful and unuseful ways. I don't see how anti-sun is necessarily a useful thing, but for them it was a thing. And their use of gnomon, though, that is a thing to celebrate about being near the equator. I'm just like enthralled with this concept. So yeah, they had sun temples that were places where people got sacrificed.
Right. Yeah. Yeah. You
They
need to
had
know the exact
astronomical
right time to sacrifice somebody.
they had astronomical observatories for observing the sky. They had gnomon for observing the changing of the dates and for literally climbing to get closer to the gods. And for them, it was all one. It was all united.
Wow. All right. So next week, which for us is going to be in about 4 minutes, we will be talking about the modern astronomy in the region, which is, of course, out of control. It's crazy.
That's an understatement.
Yeah.
Oh, dear God.
Yeah. So we will get to that in a second. But before we wrap up today's episode, do you have some names to
I
celebrate?
do. I do indeed. Today, we would like to thank for their support over on patreon.com/astronomycast. You are the people who keep us going month after month and let us pay Susie. I'm saying thank you for Susie and all of us too. So thanks to Elad Avron, James Plate, Nate Detweiler, Merrick Verderlin, John Drake, Jeff Collins, Sylvan Vestby, Thomas Supstrup, Richard Riviera, Greg Thorwald, Frank Trippin, Bill Hamilton, Jim Smith, Kjartan Sver, Helga Bjorkheim, Joseph Hoy, Dana Norrie, Emily Patterson, Les Howard, Corey Diwali, Joss Cunningham, Robert Plasma, Laura Kittleson, The Great Nothing, David Troy, Brian Cagle, Andrew Polstra, Ramji Anoftu, I'm so sorry, Burry Gowan, and Jordan Young. And I adore all of you, and I apologize for everyone whose name I continue to mispronounce with gratitude month after month after month. Thank you for making us possible.
Thank you so much. We'll see you all next week.
Bye bye.
All right.
And now we save.
All right. Just fix this. Save that.
This, I don't know the episode number.
529.
Okay. We stop Dropbox. Stop. Add Dropbox. Bad. Okay, there we go.
This is weird. It's all right.
You're good.
All
You're
right.
good.
Okay. Close that. Start up another one.
Yep.
Let's fast forward a week.
I'd rather not do that, but I also would because I don't like the whole like flying 10 gazillion hours.
Let me know when you're ready.
I'm almost ready. Almost. I I am ready. Ready?
I'm ready.
I pressed record.
I've also
Hello,
pressed record.
Susie. There's a massive fire truck outside. Sorry, Susie. We're waiting.
I learned an interesting trick that someone did, which was as a way to synchronize the audio. So we should try this and see if this helps Susie out. Take your headphones out, put it next to your microphone, and I will clap so that my audio comes through your microphone.
Okay.
That makes
Here we
sense?
go.
Let's try
Yep.
this. So put your head right there. There. Done. Did you get an audio spike at the moment I clapped?
No.
Oh, well. You probably
I
have,
guess my
like,
audio is just too soft.
yeah, you need the bigger headphones. So,
Yeah, it also may be canceling because these are my monitors as well. I
right.
have no idea.
Oh, well. So much for that idea. If Susie can
Sorry,
see it, she
Susie.
can. Anyway, let's get rolling. Astronomy Cast, episode 530, Modern Astronomy in South America. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing? It's been so long since we've talked.
I know. It's been ages and ages.
As if, like, maybe 4 minutes, maybe 5 minutes.
Yeah, it's true.
And that's because we're, of course, recording 2 episodes while you can head off to Budapest, and we will be able to take a week off while you do this.
It's true. And I'm sorry, Susie. My dog is now squeaking with the fire truck in the background because this is what she does. She sings with the fire trucks.
Your dog sings with the fire. There's no need to apologize to Susie. We are leaving that in. So this just saves her time because you didn't have to think about it because that is so awesome. I love it. That's so adorable. All right, South America, especially the Atacama Desert in Chile, has become one of the best places in the world to put a telescope. It's dry, high, and the nights are clear. Today, we'll talk about the monster telescopes already in operation in this region and the big ones coming soon. Have you been to the Atacama Desert ever? No?
I have not.
No.
And it's one of the places that's still on my to-do list of places to go
Yeah.
observing. And I'm a little bit annoyed because when I was a graduate student, I was given the opportunity by one of my undergraduate advisors to do an observing run as a favor for him. But my graduate school advisor was like, no, you need to stay here and focus on your research here. And so I missed out on a chance to go to Cerro Tololo, and that would have been amazing.
Paul did one of the astro tours. They went to Atacama, and they went to Paranal, I think, and saw ALMA and some other observatories. And I know Brian Koberlein he did a trip to the Very Large Telescope. Yeah, I'm so jealous. It just sounds like an epic place to go and check out. So if anybody listening wants us to come and do a special episode of Astronomy Cast from Chile, you just let us know, and also pay for us to come.
Yeah,
because it's really far and really hard to get to and very expensive.
Which is why it's all true.
Yeah. But yeah, so let's talk about what are the observatories that are there in mostly Chile.
So those of you who are watching live are currently watching me like flip all over my screen because I don't even know quite where to start because there's so many observatories. They go on and on forever.
Just pick one randomly right now, and then we'll just noodle around. Paranal.
I think it's about the most northern of all of these different observatories. And so you might be thinking all of these observatories that people mention out in the Andes Mountains in the Atacama Desert, how big could that be? Big. The answer is very, very big. They are spread out. If an earthquake affects one, it may not affect all of them. If you think you can do them all in a single trip, you are probably wrong.
Yeah.
Um, so Serra Paranal is about the most north of all of these. It is at 24 degrees south. And this is the facility where the very large telescope, all
Right.
four of the multimeter scopes, their 1 meter companions, all of them are located right there. And that's not all.
Now, how much would you pay? Yeah.
Along with the VLT, we also have the Vista Survey Telescope, the Next Generation Transit Survey, and the VLT Survey Telescope, which is separate from the VLT itself. So this is just basically a mountain that has been flattened using a great deal of explosives, which is something they do out there. They blow the tops off mountains. These are not currently sacred mountains, and
No.
as we talked about in the last episode, the conquistadors kind of got rid of the Incas, so we don't
Right.
know these things. Uh, but so we just kind of blow the tops off mountains because we can.
Hmm. So let's talk about some of them. And of course, I think, you randomly chose the essentially largest telescope in the world. So let's
Of
talk about
course.
that. The Very Large Telescope.
So the very large telescope is an array of four separate 8.2-meter mirrored telescopes that have adaptive optics, which means they can flex these telescopes. They also have technology on the secondary. They can get images using this suite that are as good, and in some cases better, than images from the Hubble Space Telescope. And because they have so much more light gathering power, because it's like four 8.2-meter telescopes, and they have four ancillary telescopes that are each 1.8 meters across. When they get to combining all of this stuff, they can see super faint and super high resolution.
And the key to these four, I guess, eight telescopes all arrayed
Yeah.
together is that they get to use this technique called interferometry, which people are always asking us, like when the Event Horizon Telescope takes its picture, a telescope as big as the Earth, why can't we make a visible telescope as big as the Earth? We can't because it's hard. You need to align the telescopes very carefully. Well, here's a place where they have aligned the telescopes very carefully and they act like one telescope the size of their baseline.
And the way this works is they use fiber optics. And by shifting all of the light to get it delivered to a single place, and by adding in some additional tricks with mirrors and light distance changing devices, they're able to get everything synced up just right so that it is as though the light is hitting all of the mirrors simultaneously, even though they're slightly different distances from the stars, and that matters for light. Uh, they can physically move the wavelengths around to line them up. Now, this is done in the infrared. It's not done in blues, it's not done in ultraviolets. We don't have the precision to do this with that short of a wavelength. And this is just some of the world's most amazing instrumentation. And even as we start to get into this era of the overwhelmingly large and massively large, and come up with whatever acronym you want,
Extremely
large.
large?
Yeah, yeah. As you come up with these, I really give it to the VLT for finding its own way to get there and get better resolution than those scopes are going to get in some cases.
Right, but the next, it's, this next generation, the extremely large telescope is coming. It's going to be built 2035, sorry, 2025, I think. So we're still the 20, yeah, we're about 6 years away, and it's a 39-meter telescope.
That
So
That's
And that's going to be there too.
true.
So that's going to be in the same
Yes.
spot. So that will be a very capable telescope. But it's going to be
And
a single scope made with a whole
yeah,
bunch of segmented mirrors as
yeah.
opposed to a bunch of separate telescopes. So it's going to be a different creature, and it's going to be able to do things like um, detect the motions of Earth-sized worlds orbiting sun-like stars purely through the radial velocity measurement, and also be able to observe them directly. So,
And I just want to catch you. The Cerro Tololo, sorry, the Paranal Observatory isn't going to be where the extremely large telescope is built. It's being
10
built
kilometers
somewhere.
south.
Yeah, so
Yes.
it's close.
Yes.
It's close,
Yeah.
but not like the whole place.
Right.
You can't take a four-wheel drive vehicle without hitting an observatory or a mining complex. Pick one.
Right. Yes. Sorry. But very different from some of the other observatories.
Yeah.
The other ones are hundreds of kilometers away. So,
Yes, that's true.
yeah. But as you said, and we don't want to gloss over the others, the Vista, the VLT, the Next Generation Transit Survey, the new Cherenkov telescope array that's coming in. But let's move to another facility.
Okay, so we are going to just skip over them, and that is
I
okay.
just I just gave them some love.
You gave them some love.
Yeah.
I'll give you
But like
that.
think about it, like Alma's there. Uh the
So,
Gemini South telescope. Anyway, please, I'm getting too excited.
moving to the next big mountain uh, down the ridgeline. So here we get to La Sille Observatory. This is at 29 degrees south latitude. And this is where the European Southern Observatory Schmidt telescope is. And this was one of those first telescopes to do massive wide field imaging in the Southern Hemisphere. And this is really where the Southern and European Southern Observatory comes from. This facility has scope after scope after scope, and the photo of it makes Kit Peak look tiny. So it has the ESA 3.6 meter telescope, the New Technology Telescope, the MPG ESO 2.2 meter telescopes, the ESO Schmidt telescope, the Euler telescope, Mascara, that is actually an astronomical facility, the REM telescope, Taro, the Danish 1.54 meter telescope, and of course, the TRAPPIST
Right.
Observatory.
So the one that discovered the red dwarf with all of
Oh, yeah.
those Earth-sized worlds orbiting in the habitable zone
Yeah.
is located on this in La Silla. Yeah.
Lucilla. Yeah. Lycia. I'm not sure. Uh, but TRAPPIST stands for the Transiting Planets and Planetesimals Small Telescope South. And this cute little facility, uh, it's just a 0.6 meter telescope, but it's finding worlds. Um, yeah, it's awesome.
And that was like the original facility for the European Southern Observatory. Is that right? That's sort of where they started. Like, it's been around like since the '60s, right?
It has this is one of the older facilities. It was uh, approved to be put together back in 1963. It's not too far from Santiago, 600 kilometers, which in a big empty desert, that's about 400 miles. It's not too bad. You can do it in a day.
A
Uh,
long day in the desert.
it's a really long day
Yeah.
in the desert. But by 1976, this is where they had a 3.6 meter telescope. And for the 70s, 3.6 meters is huge. And that 3.6 meter telescope just made knockout discovery after discovery and paved the way for all the science that we're now seeing today in the Southern Hemisphere.
Where would you like to go now?
Oh, man. Is that all the love we're giving to that
We can
particular
definitely talk. I
facility?
mean, any discoveries you want to make. Any we talked about TRAPPIST. Uh, pick. I mean, if there's any other instrument that you want to talk about, that you have any personal experience with, by all means, now's your chance. But there are also what 20 different facilities in
Oh
Chile.
my God. I know we're not going to get
One,
to all
two,
of
three,
them.
four, five. ALMA.
Yeah.
There's where the Geminis are at Cerro Pachon,
Mm-hmm.
Cerro
And
Tololo, Las
and so
Campanas.
Sarah Tolola was the one I was going to go to next
Let's
because
do it.
Sarah Tolola is another one of those classic facilities that has been around for a long time. It is actually kind of known for all of the things it no longer has. It used to have the U.S. Naval Observatory's astrograph 0.2 meter telescope that gets used to figure out exactly where you're pointed. So this is how we set our observatory coordinate systems. Uh, they did a H alpha sky survey from down there, and this is also a facility that has um, basically rent a pad is not quite how they put it, but I don't know how else to describe it. This is a facility where pretty much anyone who wants to stick something in the south sticks it there. So we have what are called tenant telescopes. This includes the Global Oscillations Network Group, or GONG, which is a facility. There's a whole bunch of these around the world so that they can have 24-hour continuous views on the sun. And with that 24-hour continuous view on the sun, they were able to actually measure, before we had spacecraft up there observing the sun, the tiny pulsations that are caused by astroseismology, basically starquakes in our nearest star. So that's a sweet system for me, just because that was how I learned that everyday stars pulsate too. So this is also where Las Cumbres Observatory, their telescope network is going to be building a facility, and of course,
Say it. Say the words.
this is where the Large Synoptic Survey Telescope is
Woo!
going.
Yeah.
This is the telescope to end all hard drives. For
I love
lack,
that.
it really
Yeah, it
is.
totally is. Yeah, the hard drive ender.
It's just going to be another 8.4-meter telescope, so it's not really bigger than any of the VLT telescopes.
Well, 2 meters, 20 centimeters bigger.
That's in the noise. It's not really in the noise, but
Yeah.
pshaw, nonetheless. Uh, so this 8.4-meter telescope that was originally expected to see first light by 2015, which has come and gone, and we're still waiting because it's harder to build than we
Yeah.
thought. This particular telescope is going to be surveying the entire visible sky every few days
Yeah.
and turning in like petabyte a night, a million transient phenomena a night, maybe. And so these are these supernovae. These are the variable stars, the flare stars, the asteroids, the Kuiper belt objects, all those things that move, flicker, and flare in the darkness. It's going to detect all of them. One of the fundamental justifications for funding it was to find any potential Earth-killing asteroids. Uh, we, depending on whose information you read, are missing tens of percent of the objects that should be out there. This means there's a whole lot of rock and ice and combinations of rock and ice in orbits that potentially even cross our own orbit that we haven't identified. And LSST is going to find all of them in
Right.
theory.
Yeah, I mean, one of its things is it's going to fulfill on the requirement. I think Congress, someone put forth that they needed NASA to find all of the 100-meter and above asteroids out there in space, and LSST, people have actually
That's
struggled to
its
do
job.
this, and LSST is just one of its many jobs. We'll get this done within about 10 years. It's just going to find them all.
And the way I look at it is we justified its funding in a lot of ways by saying, "Thou shalt make sure the Earth does not get destroyed without foreknowledge of its impending doom."
Right.
The protecting us from that doom is somebody else's problem. It it was justified to do that, but the same techniques that you use to do that are also going to turn up like all the galaxies, all the stars, all the dwarf stars, all the variable stars, all the
Yeah.
and because we're going to have this amazingly rich time series data, we're going to learn more about how black holes flicker when they are in the centers of distant galaxies. We are going to learn more about just about
Yeah,
everything.
I mean, just a great example is like just in the last couple of days that you're listening to this, it looks like LIGO and Virgo have detected a black hole eating a neutron star for the first time, and that would create a flash of dead neutron star in the sky, and that's the kind of thing that you would go, oh, it looks like we saw a neutron star get eaten 4 days ago. Check the LSST data. Yep, there it is, right? Because you can look at the whole sky. So it's just going to be a phenomenal tool for this new multi messenger astronomy age that we're entering. So really excited. And I would, we could talk about LSST all day, and I guarantee that we will in the future. But of course, according to Pamela's rules, it has to function first before we can have that conversation. So let's move on to another place.
Okay, so the next place we're going to is the one that I'm going to struggle to pronounce the most, which is why it's going to probably be the last one we linger upon. This is Lano di Chajnator. I know that's so wrong. I'm so sorry, folks. Observatory that really, if anyone can add pronunciation information to Wikipedia, that would be the most gloried thing ever.
Llano
Anyways,
de Chanjantor.
this facility at an altitude of 4,800 meters is where the Atacama Large Millimeter Array is positioned. This is the most equatorial of the telescope facilities we have brought up today. It is at 23 degrees south latitude. And it is this not just a peak, yeah, sure, there's peaks, but this is also a vast plain that is covered in telescopes,
Yeah.
as all good plains should be.
Yeah.
So the Atacama Large Millimeter Array, which lives out there at this fabulous facility I can't pronounce, uh, it consists of 54 12-meter and 12 7-meter antenna that are used to detect millimeter length wavelengths of light. This is a multinational collaboration that includes all the regular characters. We have the National Radio Astronomy Observatory, the European Southern Observatory, and of course the the National Astronomical Observatories of Japan, NAOJ. Uh, so we have that. We also have the sub-millimeter Atacama Pathfinder experiment, also known as APEX, which is operated by a consortium run by the Max Planck Institute. And these telescopes are giving us a completely different view on the sky than all the ones that we talked about earlier. All those earlier telescopes were working in the same wavelengths our eyeballs see, in the infrared, in wavelengths consistent with what snakes and some other things see, and further to the red outside of what biology deals with. Well, here we're starting to get into the kinds of things that you can record all of your data local and combine it later.
Right.
and and this is where with the Atacama Large Millimeter Array, it was part of the Event Horizon Telescope.
And submillimeter is just this perfect wavelength, as you said. The universe does interesting things at this specific wavelength, and to have this gigantic telescope, I mean, again, world class. I mean, it is the radio version of the Very Large Telescope. and
And
again, located in the same region.
and this particular site is so high and so dry that they've used it to build radio interferometry systems that were designed to study the polarimetry and the cosmic microwave background, to study the anisotropy in the cosmic microwave background. This is a place where no water is getting in the way of your observations, essentially.
I c- I've never been to that kind of an altitude. Have you? Like, that's like
I
4,500 meters. Like, I
so
think the
so
highest I've ever been is maybe 3,000 meters. I've been to like 10,000 feet. I've never been much higher than that.
Yeah, I'm looking up the altitude of Taos. It's nowhere near that high. Um, I think the highest that I have been is down at Mauna Kea, and it's not this high.
Yeah.
This is the kind of place where they kind of go, here's your oxygen when you arrive,
Yeah. Yeah.
and
If
you
you have
take
trouble
your
breathing,
oxygen.
yeah, enjoy this. If you notice your lungs are filling up with fluid, go lower altitude.
Yeah, yeah. So definitely stay at a different altitude and acclimate for a little while before you attempt to go up there if you like yourself. Now, if you don't like yourself, all bets are off. Go ahead, go all the way up, but I wouldn't recommend it.
There's one more that I want to mention, which is the Gemini South telescope, since it's a
Yes.
good Canadian telescope. And where is it? I know it's in Cerro Pachon.
Okay. So it's another one of those adjacent mountain kind of facilities.
Yeah,
And the Gemini system, this is aptly named. Gemini, of course, are the twins in Greek mythology, and Gemini North and South are located in Hawaii and down in Chile. And between these two twin facilities that are designed so that if you know how to operate one, you know how to operate the other. If you know how to reduce data from one, you know how to reduce data from the other. They're designed to get matched observations of both hemispheres of the
right.
sky. This follows in the grand tradition of the North and South versions of the Palomar Sky Survey, and it's just these are some of the early massive telescopes. They're 8.1-meter telescopes. Here we're looking at something that's at 30.2 degrees south, and I'm not sure what to say other than this is just another one of those brilliant systems for figuring out how do we get a better view on the sky. With the very large telescope, they were trying to solve the problem of how do we get the highest resolution possible. With the Gemini North and South, they were trying to solve the problem of how do we get matched deep observations of the sky. And so they built two massive telescopes, two different places. Keck 1 and 2, it follows the same model as the VLT where you have matched telescopes side by side. Gemini is really one of those, the only ones to do, other than the Schmidt telescopes, to do this. Let's just go big or go home and do it in two very different, hard to access, very difficult to build in locations.
And I think we're pretty much out of time, and we could easily talk about another probably half dozen spots in South America and some of the really interesting observatories that are located there. So I hope at least that just gives you the general sense that if you want to see telescopes, plan a trip to Chile and go on a road trip, and you will see all the telescopes you can handle.
And there are a variety of upcoming solar eclipses passing through the
Yep.
area. So, hey, check out the Astro Tours. And these are nations, this is a nation that really welcomes your dollars.
Astrotourism.
Yeah, your astrotourism dollars.
All right, Pamela, before we wrap up, did you have any names to thank this week? Are we
I
caught up?
do. I need to thank Merrick Verdarni, James Platt, Dave Lackey, Philip Walker, Paul Disney, Chris Scherhofer, Cooper, Matt Williams, Karen Spence, Scott Bieber, G4184, Jason Graham, Stephen Lutking, William Jones, Bart Flaherty, Sarah Tumble, Father Prax, Kenneth Ryan, Anna Usar, Martin Dawson, Russell Petto, Paul Veller, and Dean.
Thank you.
Thank you. You are what keep us going. And I apologize for mispronouncing your names month after month.
After
This
month.
does not stop my
No.
gratitude, but it augments it with sorrow.
All right. Thank you, Pamela. And we'll see you. People will hear you next week. I will see you in 2 weeks.
Bye-bye.
Bye, everyone. All right. And I hate to do this, but I've got to just wrap this show up, and I've got to go. So sorry we couldn't do any questions today, but you got 2 shows. Thanks, everyone. Thanks to the moderators. Thanks, Pamela. We will see all of you in 2 weeks. I'm trying to think of anything interesting coming up. I'm going to be doing an open space on Monday. We've got a weekly space hangout next week, so come on back.
So, super secret announcement. We are in the process of relaunching Moon Mappers to do science on CosmoQuest, and we are going to, in the next couple of weeks, be hopefully mission willing launching Bennu Mappers to find the rock.
Is this an announcement or a secret? Which is it?
It's a secret.
Announcement.
It's a secret announcement.
All right. Shh.
So, shh.
All right. Thanks, Pamela.
Bye-bye.
Bye.